ACC represents the companies that are involved in the business of chemistry. Just to give you a little scope of what that means. The business of chemistry is about a $674 billion industry in this country. Directly employs about 800,000 people. Indirectly, when you look at the suppliers and the companies it touches, it's responsible for about 5 million jobs in this country, directly and indirectly. But I wanted to talk a little bit about automotive today. When you reduce weight in a passenger car, of course you're increasing fuel efficiency. We talked about that. When you improve fuel efficiency, you're also reducing emissions. They go together. So there are other things that plastics and plastics composites do for cars, is they enhance safety. Just about every single safety innovation that's in a passenger car today is enabled because of plastics. Whether it be the airbags, whether it be the driver's side airbag, the passenger side airbag, the side impact airbags, are all enabled because of the use of plastics in those assemblies. Windshields, plastics that's involved in the windshield inner layer. And when you talk about crumple zones and then inserts inside the car, everything to do with protecting the passenger in a crash. So all the soft parts in cars, the places where you can hit your head, are all made safer through the use of plastics. Plastics allow the engineers and designers to design the vehicles with the aerodynamic features they need to be able to make that car slippery through the wind so they can get this fuel efficiency. It also gives them design flexibility that they can't get with steel to get the features that the consumer wants to make a good-looking car. And that's really important. When you substitute plastics and plastics composites for other materials in the vehicle, typically metal and glass, you're making components with those that are typically about 66% lighter, because metals and plastics are anywhere from 2 to 3 times heavier, or lighter, than metals for the same parts. Every 10% you reduce the weight of the car, you get about a 6 to 8% improvement in fuel economy. And that builds upon itself because as a car gets lighter, the engineers can also redesign all the subsystems to take advantage of that weight. Things like drivetrain, brakes, etc. can all be optimized for that weight. So when you use plastics to lightweight the vehicle, the reduction of greenhouse gases you get from lightweighting using plastics is more than the greenhouse gases that are generated when you produce that plastic. So you get a net decrease or improvement, whichever way you look at it, of greenhouse gas reduction throughout by using plastic. So this is a win-win. What's on this chart is the result of a study that was done by the Society of Automotive Engineers in 1998, looking at a standard generic passenger car. And what's shown here is 2 charts. One shows the energy consumed, and one shows the CO2 emitted for 3 phases of the life cycle of the vehicle. The production phase, making the car. The use phase, which is everything from the dealer having the car to when you finish with it as a consumer, and disposition, which is what happens to the car at the end of its life. In both cases, you can see whether it be energy consumed or CO2 emitted, the use phase dominates the contribution in those areas. So by using plastics and plastics composites, you're impacting the most significant phase of the life cycle of a vehicle. This is an example of a running board. It's usually 2 per vehicle, of course. It's an example for one. It's a General Motors running board. The part on the left is pretty typical construction, steel over plastic with brackets, the fasteners, etc. You can see there it says there's 29 parts, about 30 pounds, 28 pounds. General Motors worked with their supply base to redesign that part and made it into 1 part, structural components, plastic composites, cut the weight in half, so 13, 14 pounds versus 28 in 1 part. So net savings on a vehicle for this would be 28 pounds for 2. A significant reduction in weight. It's also cheaper, easier to assemble with less issue for the car maker to put it in, as well as the consumer later to service it. With this in the back, this is a progression of a radiator support we call a bolster. This is where your radiator would bolt on. And you can see this is for the Ford Taurus type car. The progression from 2005 2008, they were improving the part but not working on weight. 2010, Ford worked with their suppliers aggressively to reduce weight and make this a more simple part using complete plastics and plastics composites, including the load-bearing areas and the slam area for the hood, which is very critical, dropped it down to 9 pounds, about a 30–40% reduction, and made it one part. Again, this isn't as sexy looking at the outside of a vehicle, but this is the type of structural application that you can see in cars using these materials. The ACC works with the executive branch, DOE, DOT, and NHTSA. And a couple areas I wanted to highlight is participation, predictive engineering research, as well as recycling initiatives for the end of the vehicle's life. And that work's been going on since the early 90s. When we talk about using these components in vehicles, predictive engineering is important because the engineers, to include more of this material into the structural parts, need to be able to know how it's going to work in the use of the car and how it's going to react. So they need models to do that, and this predictive engineering work provides them that models. The work is done and is made public to the engineers to use as they design vehicles. NHTSA has developed a safety roadmap for the safety benefits of the lightweight and plastic composite intensive vehicle, the acronym of PCIV. And intent here is to continue to lightweight vehicles using these innovative materials, but maintain the safety of those vehicles at the same time. That work is included and reflected in the pending Motor Vehicle Safety Act, which includes provisions that continue this work for the development of these lightweight vehicles, use of these lightweight materials, while ensuring existing safety parameters and improving on safety.